recording. I want to make sure I can send it back out. All right, now we're recording. And we just went through setup. So what this workshop is, it's hopefully a super friendly introduction to computer vision. It's kind of designed for, no previous experience is expected, but knowing some Python will be very helpful once we get to the coding portion. But I will be walking through what's going on. So if you're new to Python or if you're new to programming, don't worry, just stick through it. And there might be some things that are a little bit over your head, but I think you'll do okay. We'll cover applications and basic intuition on some concepts and showcase different types of computer vision models. Then we'll go into hands-on how to label your own data set. And then we'll jump into code and how to train a model with a labeled data set. You totally can't learn everything in the computer vision field in 2 hours, but you can learn enough to get started and excited about the field. And again, depending on your experience or background, parts of this may feel a little fast-paced or challenging, but that's totally okay. You'll learn a lot, I think, by sticking through it. And then it's very important to keep learning after this workshop. So I'll point you to some resources. I'll also be hanging out after the workshop so I can answer any other questions that I don't answer as we go. About me, my name is Sage Elliott. I'm a machine learning developer evangelist at Sixskill, sixskill.com. We do some really awesome stuff with machine learning, computer vision, and IoT. We work a lot in the computer vision space right now, and we're also making tools around that space to make it easier for everyone to build their own models and deploy those things in the field. About for the past decade, I've worked either as a software or hardware engineer with startups and agencies, either in Seattle or Central Florida. And I really love making things with technology. Stay connected with me. You can find all my links at sageelliott.com. I'm on Twitter as Sage Codes, and then LinkedIn, I'm Sage Elliott, 2 L's and 2 T's. I should come up. About you. So normally, if we're at an in-person event, I love going around the room, having people introduce themselves. But there's a lot of you here, and that would take way too much time. So one of my favorite things to do right now in the current state of the world is to stay connected. And I shared this out earlier, but there's a Slack channel. So if you want to go in there, introduce yourself, talk to other people in the field, join me there and say hello. And then also ask me any questions. So after this workshop, people will often ask questions in there about labeling either their own data set or training, and that's a good place to do it. But real quick also, if you want to, you could post in the chat where you're watching this from. It's always fun to see kind of where everyone is in the world watching this workshop. And as you're doing that, just to set up a repeat for everyone who came in. Cool, seeing people all over. Always super fun. I'm always surprised sometimes where people are. They'll be like someone joined the chat earlier and said good morning. So I'm assuming they're in a different country. Very cool. Someone's from Berlin, Germany. Welcome. I am in Seattle. I forget if I said that or not, but so I'm in Seattle in the Pacific Central Time right now. Awesome, welcome everyone. And again, really cool seeing where everyone's watching from. And then set up again, just for anyone who joined, all you need is a modern web browser, Google account to use the data science tool that we're going to be coding in. And then again, you just sign up for the free trial here, and we'll use it for labeling. All right, so what is computer vision? It's a pretty big field, but I would really just kind of boil it down to how computers gain understanding from images or videos. There's other types of data as well that you could think about as video that aren't necessarily videos or images. So audio, for example, you've probably seen visualization of audio in image format. I think it's called I always get it confused if it's a spectrogram or a spectrograph. It's one of those, you've seen visualizations of audio, and you could use computer vision to look at those audio signals and, either recognize words or if something like a gunshot happened. And then there's also 3D types of data like MRI or LiDAR, which isn't quite a 2D image. It's kind of a whole bunch of different clusters of points in a 3D area. And that's often kind of considered computer vision as well. But here's a quick little example. So we have this model. It's trained to recognize trucks, and we'll talk a little bit more about what this is. You can see it's drawing a box around it, but it's also drawing the pixels on the actual trucks itself. So the box, if it was just doing the box, we would call that object detection. It could classify that it's a truck and draw a box around it. Since it's drawing the pixels around where it actually is, this is a instant segmentation. So it's actually segmenting where the entire object is and coloring in those areas. And then in this case too, it can also see when a truck is moving or when it's not moving. So it's doing a form of tracking and seeing that, hey, this object is moving, right? And it got it wrong a little bit there. But as it kind of moves across pixels across the image, we're going to classify as a moving truck versus a stationary truck. So why I love computer vision, I already talked a little bit about it, I think, before I started recording as people were joining. I think it's a really awesome field right now. We're doing really cool stuff with it today. It's an amazing interface to the world. I mean, so many things that we do as humans use vision, and now we're starting to do those tasks with computers. So we'll talk about some of those applications. So who uses computer vision? More and more companies are using it across multiple fields. Here's some examples that you've probably heard of and maybe some that you haven't thought of. So in Seattle, I don't know if anyone's heard about this company, but we have a local company called Amazon, and they have a really cool store called Amazon Go. I don't know if anyone's been into one. They're not in that many cities, Amazon Go yet. Has anyone been into an Amazon Go store? Someone said yes. I know some people said they were from Seattle here. So, and yeah, I think they're in several cities now. I don't remember which ones, but it's really interesting. They don't have a checkout line or someone to check you out. It's using all cameras. And if you look up, it's like these giant arrays. And I think there's some processing units with like, I'm assuming GPUs up there to actually process video real time to kind of see. So you scan your phone when you walk in with the QR code, and then you pick items off the shelf, and then you walk out, and it feels like you're stealing because you're not checking out. So the first time I did it, I was like, this feels so wrong. But now I've been to them quite a bit because I live close to one, and I'm kind of used to it. So now I'm kind of worried that I'm going to go to other stores and just pick up items and walk out. But it's really interesting too, because if you go to their Go grocery one, they you actually shop normally for like fruit and stuff. Like you can rummage around and pick up fruit and put in your bag, and you still get charged, at least in the times I've gone, charged correctly every time for it. So that's pretty interesting that they can calculate you moving around and not just picking up things off shelves, but also just in things like fruit bins, which is really cool. They're working on delivery robots, self-driving cars. Quite a few people in the chat earlier said they're interested in the self-driving car industry. They look at product listings, like when you upload images to it. Google, probably maybe use Google Photos. You can search for things like dog, and I'll bring up all the pictures of the dogs you took, or all the pictures of dogs you took. YouTube filtering, self-driving cars, Tesla, self-driving cars, Facebook, FaceTime. These are kind of examples you've probably all seen or heard of a lot. But here's other fields that not everyone always thinks about. So like agriculture, crop monitoring, animal monitoring, construction, site monitoring. So I've seen some companies working on self-driving tractors, which is really interesting, like how to navigate work sites and like see where to put things. Like, I don't know, this seems really interesting to me. Manufacturing, quality assurance, throughput, supply chain. This is actually what got me interested in computer vision and kind of the whole data science space. Was I was working at a company where you're manufacturing a really complicated part, and I could take that part around to different people in the office, and they would give me different answers if it was good or bad. So I actually was like, okay, I could probably make a more reliable system using computer vision, and that's how I kind of jumped into the space, which was really cool. Oil and gas, so like leak detection, safety, healthcare, X-ray diagnostics, MRI scans, medicine research. And this isn't, by any means all the fields or use cases, but these are just some that maybe you weren't thinking about. Like, computer vision in agriculture is actually a huge field right now, which is really interesting and really cool to see. Put in the chat, do you have, I see some people already talking in there, but if you have any field that you're really interested in, throw it in the chat right now. And especially if it's one I didn't mention before, because I'm sure there's quite a bit. Like generative deep learning is really interesting, where you can like generate images, original art, original buildings or faces using something called a GAN. Usually there's other variations now that are becoming really good as well. Someone said environmental applications. That's really cool. Do you have any like specific use case in mind for that? Someone said image training recognition. That's what we're going to be doing tonight. So super, super awesome. Someone said accessibility. That's a great one. Yeah. So, you know, real-time sign language translation, or even being able to just read text and read it out loud. Google's been doing really cool stuff with that, with translation, or even not quite the same for computer vision, but an app around that I thought was really cool is they had a phone app that could hear a noise like a bird or something like that, and it would show an image that a bird was making noise for people that were deaf, just so they could kind of experience the environment more. Someone said smart agriculture. Yeah, that's really cool. Northern CA fires. Yeah, fire detection would be awesome. I've always kind of been brainstorming in my head how that could be better. I don't work in the field, so I'm sure it's really hard, but it'd be cool if you had drones or something that can maybe monitor an area where you think is highly susceptible to that, and say, hey, there's a spark over here, or a small fire. Hopefully we could try to catch it before it becomes a big fire. Someone said fires in Australia. Yeah, fires everywhere. Be awesome to stop them before they get big. Super resolution. That's a really cool, interesting topic. So you could take a image that's low resolution and then make a high resolution image from it, or a higher resolution. All right, so I'm going to keep moving on because I know the more exciting part is the hands-on. We're going to get there pretty soon. So computer vision and deep learning. Computer vision isn't always tied to deep learning. It's kind of a very broad field, but most of the things you're going to hear about that are coming out recently from big companies, they're using deep learning to solve these really complex problems. So like things like we talked about Amazon Go, like recognizing humans, recognizing specific objects and stuff like that. Most of the time, that's going to be a deep learning and computer vision application. So a lot of other intros will go way more in depth around kind of just how deep learning works on its own, and how neural networks work, and convolutional neural networks, which is what's actually used most of the time in computer vision right now. I'm going to give just a super high overview of deep learning, but almost any other resource you go through will dive much deeper. But I kind of want to get to some really cool stuff like creating data sets and then training a model with Python. And it's going to be super hands-on. You're going to come away again with all the stuff that you need to actually do this kind of to start solving your own problems. But then you'll want to go and fill those gaps of theory that we kind of glossed over. So I shared some links. This is kind of a cool area to kind of play around with a deep neural network if you've never seen one before. And then this is a really cool visualization of a convolutional neural network. And again, we can talk more about these after the workshop, or you'll want to dive more in on them on your own. But on a very high level, deep learning kind of works like this, and kind of the same for a lot of machine learning, any kind of supervised machine learning type problems. And it works kind of like you have a function, and you could imagine this as a mathematical function, as a programming function, just kind of make a concept of this right now. And you're going to pass this function a whole bunch of training data. And in this case, for supervised kind of deep learning, machine learning, we have labels to that data. So a classic kind of way to get started in computer vision is you're training a classifier to classify, does an image contain a dog or a cat? And you would feed this function a whole bunch of images labeled dog or cat, depending on which one's in there. And it would kind of automatically learn what features make up a dog versus what features make up a cat. So that could be maybe, in theory, you could think like, well, like the cat's ears are always like pointy, or their nose is very similar, and dog noses always look way different. It'll automatically learn up these kind of features, that the difference between those two animals in this case. And then when we think it's trained enough and good enough to work on data it's never seen before, we would feed it a new image that it's never seen, and then it would return a prediction. So in this case, a dog or a cat. So if you gave it a picture of a cat, hopefully it would return cat. And if we gave it a dog, it would return dog. And yeah, that's very high level concept. Again, just kind of how deep learning works. In this case, deep learning for computer vision, we're training a convolutional neural network. It's just a special type of neural network, and it'll work on images. So it'll start understanding what's going on inside images, or looking for things that that make up certain characteristics of whatever you're training on. A quick note on transfer learning. So with most popular deep learning frameworks, like we're going to see tonight, you can load in pre-trained weights into your network. And these have been trained extensively on quite a few objects and animals. So often there's several famous data sets they're trained on. One is called the COCO dataset. I think it has something like 81 classes of animals and objects in there. And they're trained for hundreds, if not probably thousands of hours or something, and with thousands of images. And so they work really good at recognizing these classes they've been trained on, at least at the specific angles and stuff that they've been trained on. And then what you do is you start from there, and we take that pre-trained network, and now we say, okay, you learned all this stuff, but really we just want you to learn about our stuff now. But it turns out that taking a pre-trained network and then just kind of reteaching it to learn about the stuff you want to works really well. This is called transfer learning. So you'll see tonight that we'll feed a neural network, only something like 140 images, and it'll train in like, 10-ish minutes or something like that, and we'll get really good results from it. And the reason why we can do that is because we're not starting from zero. We're using a pre-trained network, and then we're going to give it new data to learn from, and it'll perform well. So a good rule of thumb for a hobby project, I always say, and this is really just a loose rule of thumb, is try to collect something like 200 images for transfer learning, but this can really vary on the type of data and the results you want. So typically, the more data, the better. It's just a good rule of thumb. If you're doing, like someone talked about, creating a Cougar classifier, you could also start with less and see how well it performs, and then keep adding more to it. And that's actually what often happens in the real world. Is you start with however many data, like images, you can get. Hopefully, it's well over 200, and then you keep collecting data, and then you keep training your model, and it becomes better and better. Someone asked, will you get the PowerPoint after the session ends? I'll send it in an email. I don't think it's shareable this second, but yeah, I will make sure you get all the resources. So I see a couple of questions before we get into the types of computer vision real quick, and then the labeling. Let me just catch up real quick with these. Oh, I think I already talked about what subjects will be covered today. Are pre-trained models available in 6-skill? So the pre-trained ones, like I talked about, you can start with those in our entire kind of whole computer vision sense platform. And more pre-trained specific ones, I think, will be coming out in the future. And I'm going to keep going, and then I'll come back to more questions. So some types of computer vision applications. Or types of computer vision. So computer vision is a really big field, and I'm just going to briefly go over some of the popular ones with computer vision deep learning. And then some of these can kind of be combined together or go with other algorithms on top of them to get various outcomes. So classification, I've seen some people already kind of bring this up before, and we talked briefly about it. Like if you're predicting a dog or a cat, it's going to look at the whole image and then kind of predict what's in that image depending on how it was trained. So in this case, I trained a neural network to predict dog breeds and fed it this image, and it predicted that it was a Labrador retriever. If you put in a Bernese, hopefully it would predict it's a Bernese. But you can see it's just saying the breed prediction here. It doesn't know where the dog is in the image. It's just assuming, hey, you're going to feed me images, and I'm going to give you the best prediction on what I was trained on to just classify this entire image. And if we had 2 dog breeds in here, it might get really confused because, yeah, if you had a Chihuahua over here, it might be like, well, I'm pretty sure it's a Chihuahua, but also this Labrador's in there. And it doesn't know that there's 2 dogs. It's just making kind of whatever you feed it, or the crop of an image that you feed it, it's making the best prediction that it can based on kind of the whole area. So a lot of places will start here. So if you dive deeper into computer vision with some other resources, you'll probably start with the classification. But then we have object detection, and this is what we're going to build tonight. So object detection can classify and localize where an object is inside the image or the video. So here you can see this is a picture of 2 geese, and it's say, hey, there's a goose here, and I think there's a goose here. So if you add kind of the previous example, like the Chihuahua, the make-believe Chihuahua we're putting here, and the Labrador, it could draw a box around each one of those and say, hey, I'm pretty sure there's a chihuahua here and this dog here. And then you could also do stuff here like count how many geese are in there. Do you want to do something where there's over 3 geese or something like that? This really opens up a lot more powerful kind of algorithms you can do on top of this model. And we're going to make this today. So we're going to cover how to make your own data set for this, as well as kind of the next type, which is the image segmentation. So image segmentation or instant segmentation is kind of the next level to object detection. And we talked a little bit about it when we showed the truck example. So it's drawing a box. It's really small. So I don't know if you can see it very well, but it's drawing a bounding box, kind of like the geese, but very small here, saying that this is a water bottle or a bottle. And then it's also drawing pixels where the actual object is. So it's not just doing the bounding box. It's actually saying, hey, these pixels make up that object that I was trained to recognize. And you could do different stuff with this. So in this case, we're also classifying the pixels of this water. And you could actually do something like calculating how full this bottle is based on how many pixels are overlapping with water or something like that. So if you want to get a little bit more specific where something is, something like looking at hands and fingers and actually trying to see specifically where a finger is versus just the entire hand inside of a bounding box, that can come really handy. And also the polygon labeling, which we'll talk about for something like this, tends to make a model a little bit more accurate. You have feature point clustering. So here we're estimating the pose of these people doing yoga. So you can actually see it's looking at different points. So it goes from like their arm to their hand, where their head is. And you can do things like understanding what a person's doing, how their body posture is. You can also use feature point clustering for facial kind of recognition or detection, like what mood is someone in based on how their mouth is shaped and eyes. Image captioning. This is kind of a little bit more advanced, typically where you train a computer vision model with another type of model, like a transformer or a recurrent neural network. And you can actually train something to understand context of what's going on inside of an image or video. So here, like the prediction is child flying a kite on a tropical beach. Instead of just saying child, kite, beach, it actually has some sort of awareness of what objects kind of belong together. Like the child is on the beach flying a kite, not just, the kite's flying a child or something. Generative deep learning. So I talked a little bit about this before, and it's a really fun field. I think it's really fun because it's fun just seeing the stuff that your model creates. This example here is actually something I did. I worked on a project. You can actually read more about this project here. I'll link it in the chat. We're actually working on a paper, hopefully to get published with kind of the next iteration of this. But we actually trained a model to generate original architectural drawings based on a famous architect. And this is actually, while the model is training, this doesn't look like anything like the buildings at all or anything yet. But I thought it looked like really cool art. So one day I want to get more into a generative like art bot, which I think would be really fun and just kind of create some crazy looking paintings like this. And if I see a really cool one, I'd love to, I don't know, print it out or something. There's also a really cool article here, a little bit more about GANs, and has some examples of like realistic looking faces, which is pretty cool. So those were kind of the overview of the common types of computer vision that you'll see a lot of. Out of all those ones, which actually did you find the most interesting, especially if it wasn't object detection? Like what would you want to see a workshop on next that's not just object detection? Because I might make it happen. Jerry said GAN. Kelly said generating art, GAN. Seeing a lot of GANs. Someone said audio. That would be really fun. I actually haven't done any workshop on audio. That would be really cool. Feature points. Yeah, I think feature points would be fun. Maybe I'll eventually do all of them. Image captioning. That would be cool too. Feature points. Looks like feature points and GANs are winning right now. So that maybe keep an eye out. That might be my next one. All right, so choosing a model or choosing a type of computer vision model, there could be many use cases for kind of different models. And there can be a lot of factors that actually go into choosing one kind of if you're in production. But when you're just getting started, just think about what the problem is and yeah, think about what you're solving and what is the outcome you're looking for. Like, are you okay just getting bounding boxes around something and getting like a count? Do you need a little bit more precision and you want to do some sort of calculation based on pixels versus some other pixels? You could do segmentation. Do you need to look at the posture of something, someone or an animal or a face, feature points? But really, yeah, for now, I would just say, think about those two things. I'll talk a little bit more about choosing a type of model to train because it does matter a little bit when you get into deploying and production. So object detection in a gist, and they all kind of work a little bit differently. This is a really good post that goes a lot deeper into it. So again, if you just want to look at that later or something, you can. But essentially, once you have a trained model, it'll look at your image or a frame of video, kind of finds proposed regions where it thinks something might be, and then it runs a classifier around it that was trained on your data set, and then it does some calculations based on how it found things and like running the classifier around in an area, and then it would kind of draw the estimate that it came to. To be like, I concluded that I think a goose is here, and often worked pretty well. And there's more links that go specifically into each how each actual model works at the end of the workshop. There's a whole bunch more reading you can do if you want. So popular object detection methods. You have single shot multi-box detector. It's really fast and it does object detection. So this is a really good one to keep in mind. If you're using a much lighter weight piece of hardware to run detections, this is often people's go-to because it can be pretty efficient. And then you have YOLO, or you only look once. It does object detection. It's also pretty fast. They had a new version come out pretty soon. So I'm actually not sure where the benchmarking stands now between SSD and YOLO. But as far as I know in my head, at least, SSD still might be kind of a little bit more efficient one, but that could be wrong now. And then you have mask RCNN, mask region convolutional neural network. It does object detection, image segmentation. It's very high accuracy, but it tends to be much slower than the other ones. And we have a Facebook Detectron 2, which is kind of a library around PyTorch, which we'll talk more about in a second. This is actually the library we're going to use today. It makes it really easy to get started with kind of doing a lot of the stuff we talked about. So whether you want to do object detection, instant segmentation, or feature points, this is a really cool library to get acquainted with. So you can see this video showing object detection. And some people are going to walk in a second, and it's going to do the pose, the feature point pose estimation. And then they have something called dense pose as well. So it actually draws a 3D character around them, kind of using, I'm assuming those feature points that it used, but now it's drawing a 3D character. So that's really cool. And then we'll go back. And then this is instant segmentation, right? So it's drawing pixels over all these things inside this house. And then there's another version of this too, where not only does it draw the prominent objects, but also draws in your entire background. So if you want to add a little bit more context to your model, you could use something like this. So, it sees there's actually cabinets here, a wall, a microwave. So you could have, a robot or something that understands it's in a house and it's looking at a cup inside of a house because it can see the background. Or if it was outside, you could see like sky, or I think it even does like city skylines of different kind of classes for context, which is really cool. So we're going to be using this today. And it's actually a fork of faster mask RCNN. So kind of the full computer vision lifecycle. So we're going to talk about data annotation. We're going to talk about machine learning, kind of the model selection and training, and the labeling of the data. But the full lifecycle in the field there's actually a lot more to it. And if you've ever worked in software development, you'll have some of these other pieces too. So you have like device management. So you actually need to manage the computing systems that are like running your model in the field. So someone talked about doing that cougar detector. If you were to have devices out in the field with cameras on them, and then you wanted to get a notification every time it saw a cougar, you'd have to have some way of kind of managing those especially if you have like a whole bunch of them. If you do 1 or 2, it can be pretty easy. But if you're doing a large project and there's 10, and every time you're updating your model, you want to deploy back out to those things, that can get really complicated. So you need to manage those, as well as the cameras. Sometimes they're separate. So you might have something doing computation on the cloud and then collecting data from deployed camera somewhere. So you might have to manage the incoming camera stream, have it run on a cloud node, and then get those predictions and then do whatever actions you need to. Data collection, so managing data from sensors, like if you have a camera out there, creating data sets, scraping the web for images. And then you have data annotation, so the labeling, stuff we already talked about. Then once you have a trained model, you need to deploy it. So you need to push that model out to those devices, whether it's, again, a cloud kind of node or a device on an edge device. And then typically, you want to repeat all these steps in the field, at least in some manner. So if you have a object detector for geese, and this might be a bad example, but if you have an object detector for geese, because that's where we're going to build today, and you trained your model on all images taken in the park, which is what the images are today. Well, actually, some of them aren't, and I'll actually show you why. So if you trained your model just on images of geese in a park, and then you try to recognize a goose in an environment that it wasn't trained in. So let's say it now snowed and all your training was done on green grass. The snow might really throw off that model. So typically you have changes that happen in the field based on like weather. Another good example is, let's say you trained a model to detect humans coming into your store, like for Amazon Go or something like that. And you only trained it on data that was collected in the summer. People were wearing shorts and tank tops. And then all of a sudden in the winter, they're all wearing crazy giant hats and hoodies and jeans or whatever, right? Like big coats. And if the model wasn't trained on that type of clothing for detecting humans, it might be really thrown off. So kind of you want to keep collecting all the variations that are happening in the field and then keep training your model with all those new variations. And that avoids what's called model drift, where eventually it just doesn't become as good as it once was because things are kind of changing in the environment. So typically, kind of just keep looping around in some way for all these steps. And we do all that in one platform. So not to be super salesy or anything, but if you do want to check it out, you can go there. And you can also fill out the contact form. So if you do want to have like a demo of it or something like that, let me know if this is something you're looking for, or you can email me directly at selliott@sixskill.com. And yeah, so managing all those steps inside one platform is insanely fast in here, which is really cool. All right, so we're going to get to the labeling portion now. So again, if you didn't sign up already, or if you just joined, you can sign up for the free trial here. I'm also going to pause for a second while people are signing up potentially and answer some questions, because I see quite a few in there. And again, if I don't answer them right now, like if I missed them in the chat, I will be hanging out after the workshop. So you can always ask them again later, but sorry if I missed them. Someone said, how do you use a saved model trained on images, then apply it with other weights? Well, we'll actually go over that. So in the code, we're going to train a model and save it. And then we're going to load that model back into our code and then use it. So hopefully that'll answer your question. Otherwise, it depends on the framework that you're using. So what that is transfer learning for only deep learning. That's the only context I guess I've heard it in, which, I mean, deep learning is a subset of machine learning. There's different types of machine learning applications, and everyone always talks about it for deep learning, but that's a good question. I'm trying to think, and off the top of my head on the spot, nothing else comes to mind, but I totally might be wrong on that. Someone asked what's the difference between a cycle GAN and a style GAN? I think one of them is just, the style GAN is a huge one by NVIDIA that does like those realistic looking faces. And I think I could be wrong on this one too, but I think a cycle GAN is that the one that does really good style transfer? I could be wrong on that, but if you Google cycle GAN and style GAN, I think you'll see the different applications. I want to say the cycle GAN is the one that you commonly see where like you'll have a zebra and then a horse, and it's like putting the zebra coloring on a horse. I just see some other questions. I'm going to come back to these again. I think I'll move on for now, and I'll come back to those, or feel free to ask them again as well. All right, so did people sign up that want to do some kind of hands-on labeling type stuff? You should have signed up, you got a confirmation email, and then you go into a platform. It'll look like this, but you won't have any of these projects because it will be blank right now. I've seen people say yes. Okay, cool. Yeah, to sign up for labeling, you can just follow that link I posted. Oh no, can need some lag. Yeah, so it should say you haven't created a project. Mine, I've been messing around with it today. So I'm just going to go through a couple variations of the type of data that you might work with, and then you'll be good to go really on your own projects. So. All right, so if I didn't have a project here, or let's say I want to create a new project, I'm going to hit this create project button. And in this case, I'm going to call it geese. And don't worry, I won't be labeling hundreds of images here or anything. We're only going to go through a few samples so you can see what to do when you are creating your own data set. So I'm going to call this project geese. We have this option to add project instructions. This is really helpful, especially if you're working with a team. So you can say exactly what to do, what type of label to use for each object that you're labeling. And then you can also include helpful images. So often if you're working on something really complicated, so imagine doing something in the medical industry and I wouldn't really know what a certain tumor looks like or something, or how to classify it. So I would need to have a doctor tell me how to do that. So they can leave really detailed instructions here and have even good details of a photo showing good and bad examples. Someone said, are we following along or will we do the hands-on later? So you can follow along a little bit if you want, but you don't have to. I would just say sign up, and then after the workshop, create your own data set. And that's really the fun part, is creating your own data set and then training your model with your own data set. So it's up to you how you want to use this workshop. I'll show you how to get an image in here quickly, just if you want to try some stuff out. But for some of this, it will just be, I'm just going to show you how to do it. But we won't add any instructions. Now we want to add a data source, so we can connect to Amazon S3 buckets or Google Cloud Storage, but I'm going to just upload a couple local assets. So I'm going to hit add assets here, and this is my Goose data set. I talked about how some of them actually weren't in the park, and that's because I actually did a whole separate kind of talk around doing synthetic data, and this talk actually did what I talked about, how you could recognize geese in the park, but it couldn't recognize them in my living room. So I actually photoshopped geese in my living room. So if you do look at this data set later, which you'll get in a second after we go through this, I will link to this if you want to play around with it. But for now, I'm just going to select a few images just to show. And open. I'm going to upload. One failed. Of course, doing a live demo anytime, something's going to go wrong. Let's upload another one. All right, and then if you want to add one right now, if you did sign up, you could just go to the search, or if you do have a photo on your computer, you could also upload it and kind of mess around with labeling. Again, you don't actually have to create something right now, just kind of mess around with it so you know how this works. So when you create your own data set, you can use it. I'm going to search for goose here. And we'll return some images of geese. I'm going to select this one, and I'm going to put that, just by selecting it here, it's going to go in my data set as well. So I'm going to hit add selected images. So you could do this if you just want to quickly mess around and not actually download any images or anything. I'm going to hit label schema. Oh, yeah, someone asked, can we see the platform? You can see this, right, on my screen? Okay, because the green bar did go, it disappeared around it. And I never know with Zoom, but for anyone asking, can you see the platform? You can sign up for it. Again, there's free trial, there's no card or anything required. So I definitely recommend playing around with it. All right, so here I'm gonna create a couple samples just to show. You you can get access to it. It's that link right up there. I'm going to create a couple samples just to show. Typically, I wouldn't do two of the same ones, but I'm going to have goose as a rectangle. And this color is just for you as the labeler. So we know that in this case, we're labeling geese and parks. And if it was green, for example, it might be hard for us to see. So I'm going to leave it as purple. And rectangle is what we choose for when we're doing just object detection. But then we have all these other types of labels, and we use these for kind of those other different model types I talked about. So polygons we can use for the instance segmentation. You can also train rectangles from polygons. You have points and feature points. That's for like detecting the pose estimation or the facial features. Text, if you want to just add some generic kind of text things to it. And then classification and multi-classification. So we're going to use rectangle for object detection. I'm going to hit save. And then I'm just going to create another one here. I'm going to call it goose polygon. And I'm going to hit this drop down, hit polygon. And I will change this to a more visible color. Hit save. And all right, let's go and do a couple samples. No, the photos aren't local for the search. If you want an image to mess with here, you could use the search, or you could upload your own and just kind of see how it works. But I'm just going to go quickly through this part, so don't worry too much about it. The really important thing is know how to do this, so when you bring in your own data set, you'll be able to train your own object detector. So here, if I'm labeling for object detection, I just want to get every goose here in this rectangle like this. Oops, I didn't need to click it again. And it's okay if they overlap a little bit. So sometimes you'll have, geese in this case very close together, and you can see that they overlap. This is just going to train the model to look in this box and figure out what features are going on here. So it'll kind of like we talked about with classification, it would extract features of what make up a cat or a dog. This one's going to extract features of what makes up a goose, but is only going to look kind of in this area here. And you might get the other part of the goose in that, but typically that ends up being okay for a lot of models. There are different ways of training this. So if you did have a lot of problems for whatever reason in your type of data set, you could use something like polygons, which we'll look at it in a second. And that's where you can more precisely draw around each object, and then they wouldn't really be overlapping per se, like they would with a square. Also very important is if you're labeling for object detection, you want to label every single instance of your object in that image. So for example, if I only labeled this goose, but I didn't label this goose, when I fed this image to our model, it would have a hard time understanding what I'm looking for, because it would say, okay, cool, this is what I'm looking for in here, but they didn't say I want to look at this stuff, and they look awfully similar. So it would have a really hard time understanding what a goose is, because we'd say, hey, you need to learn from this, but you don't need to learn from this. So really important, which can be like a mistake if getting started, you just don't label everyone thinking your model is going to figure it out. Oftentimes it will not. So you want to make sure you label every instance of that object here. One thing is, if it's super far away and really tiny, and you're okay that your model wouldn't predict that it's a goose, you don't need to label it. But anytime you would want it to be a prediction of like, yes, this is a goose, you want to make sure you label every instance of that. So that's how you would do object detection labeling. These rectangles, very easy. Probably, was that easier than you thought? Because when I was first getting started, I always thought it'd be hard to make my own data set for computer vision. But it turns out to not be crazy, crazy hard, at least if you have the right tools for it. So let's talk about polygons. Polygons are a little bit harder because you have to draw around the goose, right? So you could zoom way in, you could be way more precise than I'm being right now. I'm just going to do this kind of quickly. But even doing this quickly, like you can see, this is taking me a lot more time, and I'm not being very accurate with it right now than doing bounding boxes. So sometimes people don't want to do typically the more accurate kind of polygon labeling because it's time consuming. You connect it. We have a poorly drawn kind of goose outline here. So that took a little bit, and that was me doing it badly. And imagine having to do this on like hundreds of instances. So if you're creating your own object detection data set, often you'll have like over 100 things. It can take a long time to label all of them. I spent hours labeling polygons in my life, plenty of hours. And so I'm really excited. We have this really awesome new feature called Smart Polygon Selection. So you enable it by clicking this little box here. And now you get the crosshairs again, and it's just like drawing a box. So you do want to be pretty precise around the object. And then you click it, and then ta-da, it did a much better job drawing around the goose. And it took like a second versus me taking a minute. So having these smart features like this are really insane for saving so much time. And then oftentimes too, like if you're doing this for work, time costs money. So it also can save a ton of money. So if you're paying someone to label something, you know, per hour or image or something like that, or yeah, any kind of time cost thing, this can save a ton of time. So it works really good on a lot of different types of objects. Sometimes, like in this case, it may not work perfect. So you can see that, you know, the color of the cement here is kind of throwing it off because it looks very similar to the color of the body here. In that case, if it doesn't work perfect like this, you can edit it really quickly. So just click on your polygon, and this is true for if it does work, or if you manually draw them, you can always edit them later. And then you can kind of draw these points wherever you want. If you click on these little grayed out ones, this will create a new point. So you could draw, you know, as much as you want. You can actually just pull one of these down like this. And if I wanted to, you know, just make this even more precise, I can do that. So even if I have to adjust it slightly, it still saves me a ton of time doing that, and then a little bit of adjustment. So I'll hit submit on that. And just quickly again, I'll show rectangles again. Boom. Hit submit. And then let's do Smart Poly again on this one, see how well it does. Actually, I don't know. It's a little bit more complicated. And it worked pretty good. Very cool. And I'll hit submit it here. So once you do this on all of your data set, like if you chose to do polygons or rectangles, again, do it on all your images. Hit submit. Once you have those all submitted, you're good to export your labels so you can use them in your code, which is what we're going to be doing next. And you just hit export project. And we have pretty much every type that you would need to export for. So in this case, we're going to use Cocoa for the Detectron 2 app that we're going to use today, and or code. And so this is what you'll probably want to do if you're going to take all the stuff we do today and then apply it to your own data. You'll want to export to Cocoa here. And then I would probably typically leave these as defaults. We'll talk a little bit more about train, test, and validation when we get into code and actually use them. But typically, if you're doing anything with deep learning or computer vision, you often want to have a train, test, and validate kind of split between your data. And again, we'll use these when we get to the code. And then you'll see this option down here. We just submitted them. We didn't actually go back and QA them. By default, we have these unchecked here, so it will only do approved images. I'll show you how to do that in a second if you want to approve them. But that's because a lot of our customers work in more enterprise settings, so they actually have teams of labelers, and then they want someone to go approve the images and then export them. But if you're just working by yourself and hopefully you trust yourself, you can just hit this submitted annotations and then hit export now. You'll get this notification, and then you'll get an email with a download link. So if you have a really large data set, it can take a little bit to export it, usually not too long. But in this case, if I went to check my email, it should already be there. And then a notification will pop up here in a second as well. And then you just hit download. Oops, sorry, that was an old one. So they're good for several days. The download links are good for several days. Here's my new notification. If I hit download export, it just downloads a zip file. Inside that zip file, you have an image directory. So we would have all of our images in here that we labeled. And then we have 3 JSON files for the train, test, and validation split. And those are just crazy looking JSON files that kind of have the information about those boxes, about the segmentation, the different types of labels that we did, and how they correlate to that image. So then we're going to load these into our code and train our model using this. Like I said, real quick, if you wanted to go back and look at all of your images, this is actually important to note too. So by default, it shows only pending ones for labels. But if you want to go look at all images, you can select this filter here. You can go to submitted here. And this is where you could go approve them. So if I had a labeler go label all these geese, but I want to make sure that it works good, or that they actually labeled them correctly before I train my model, I would go in here and then I would hit approve for each one. And then real quick, one more thing to show before we actually get to the code. And also let me know in the chat. So what do you think of labeling so far? What do you think of this tool? Does it seem super useful? Would love to hear what you think. So here, I'm going to do an example of like this is labeling. So this is like a tomato processing kind of plant, and it's okay to have green foliage in there as well. That's not going to hurt the machine or anything. And you want to obviously have tomatoes, but in this case we don't want to have rocks, right? So in this case, I actually was training a model to detect like foreign objects that aren't supposed to be there, right? So here it's like collected samples of stuff that shouldn't be on the line, right? It's okay to have all the tomatoes, but as soon as something else is on there, maybe we want to stop the machine or send an alert to someone to come and get it out. So here I'm going to label the rock. Oh, this is a wrong label. Let me make a new one real quick. Just delete this. So we're going to create a polygon. I'll just call this rock. And I'm going to have it as a polygon. Let's go back to the labeler. So we're going to use smart poly, but we're also going to use something else. So we'll turn on that smart poly. You can click on this little arrow guy. And we're going to turn on something called track forward. We also have something called copy forward. I'll talk about both of them. What track forward does is we're going to label an object, and then it's automatically going to track where that object moves in the next frame. So it'll automatically apply, in this case, smart polygon to where it went to. This saves a ton of time. So if you're labeling frames from a video and you just kind of want to verify as you go, but you don't want to do all the labeling yourself, this is a great tool for that. So there I labeled it with smart poly. I enabled track forward. So it's actually going to see where this rock moves and then apply the label to it. If you knew that the object was always stationary and you just wanted to accurately label it and then never change that label at all, you could enable copy forward. So that's good if it's either stationary, or it's also good if track forward for whatever isn't working, because sometimes data moves around way too much, or something's really fast, or there's a lot of noise, then maybe it won't work on your data set. You can enable copy forward. So it will copy all the labels to the next frame, but you might have to manually move them around. So it's really just copy forward, copies exact location, up to you to move them. And then track forward will try to figure out where the object moved and apply the label. So here we labeled one instance of this rock. We're going to hit submit. And next frame, you can see the rock moved. It is even a different shape, kind of, because it's like moved orientations and stuff. So someone asked, so this is a video. So it was from a video. So, and they asked, rightfully so, can this tool handle videos? So currently it cannot. You have to upload the frames, but the video feature is coming very soon. So you'll be able to select a video from like a local asset, and then I'll say how many frames per second do you want broken down, and then they'll be uploaded like this. It's not in our production environment right now. So if you signed up right now, it won't be in there, but it should be coming very soon. But these frames are from a video. So, but you can see this is awesome. So it even looks way different, but it is figuring out where that rock went. So for example, I trained something using this the other day, and I was so glad that I could use this feature and just really just click this, make sure that it looks good. If it wasn't for whatever reason, I can go in again. You could adjust this. This actually looks good, but if I wanted to go and adjust things, if it draws too many polygon points, you can also highlight just an individual one when it turns white like this. Hit the backspace or delete button, and it'll get rid of that point too. So you can really clean these up in a whole bunch of different ways. And then again, when I'm done, I would just hit go to review and hit export. If you wrote instructions, you can hit the instructions button. They'll come up there. There's some other features like just for you labeling. If you had really dark images, you can adjust things like contrast and brightness just to make it easier to label. And then we have more AI assisted features coming soon. So something like auto labeling. So you can select, we were looking at the pictures of geese, you could select, hey, label all the birds in this, and it would automatically find all those birds and label using like smart poly around them, as well as in the future, the plan will be that you can keep labeling, and as you have enough labels in here, you can create, essentially your labeler becomes smart enough to know what you're looking for and automatically apply those labels to it. All right, so that is kind of the overview of labeling. Again, if you have any thoughts or opinions, let me know, and we'll go back to the code and get ready to bring a data set in and actually train a model. And then, so let me go over this part, and then as people are getting set up with the code, I'm going to catch up on the answers. Or sorry, I'm going to catch up on the questions and hopefully give you answers. So right before we get into the code, just some popular Python libraries used for computer vision. There are so many, but here are a few to know about as you get started. PyTorch, a library from Facebook for machine learning, very popular in deep learning. And then you have TensorFlow and Keras, which is kind of I think of them kind of as the same thing, except for one is made by Google and one is made by Facebook. And they definitely are different, like how you use them, but often they kind of accomplish the same things. So if you get it into deep learning or deep learning computer vision, you'll definitely be using one of these or both of them. Opencv is an awesome library for image processing and computer vision. You have NumPy. It's really great at processing multi-dimensional arrays, which is actually what an image is to a computer. We'll see what this looks like when we get to the code. We can print out an image as an array. Pillow is a really cool library for image processing as well. And again, there's probably plenty of others that you'll run into, but these are kind of the top ones that I want to put in your brain right now. So when you see them, you'll kind of know what they are. All right, so let's get to building an object detector. So I want you to go to this link. This will take you to a Google Colab. And then once you get there, so it should look like this. Once mine loads. Once you're here, I want you to go to File and save a copy in Drive. So this will save your very own copy of this. It'll allow you to edit or run anything on here, as well as if, like I always encourage people to really mess with it. So if after this workshop, you go and build your own object detector and you're trying to do all sorts of stuff in there, if you really mess it up, then you can always just come back to this original one. You can bookmark it if you want, and always just make another copy of this. So don't really worry about messing up your copy so bad. So while you're doing that, let me catch up on some questions, and feel free to ask me questions too. Again, sorry, I'm bad at keeping up in the actual question thing. I feel like I look at the chat more. Someone said, just wondering, are the images for the model to be trained for the same light intensity? Great question. So, or I think what you're asking. So if I train the images all in a certain light, like in that case, it was pretty sunny out, and then I was trying to look at geese in a darker setting, it might not be as accurate. So you actually do want all the variations of lighting changes, as well as you want a lot of variations of poses. So let me open up that data set again. If you had just geese standing up, but not them, kind of folded over, it wouldn't do a good job of recognizing a goose like this. So you really do want to think about what are all the variations that I might get. If you can think about that while you're collecting your data set, your model will probably run much better. Someone said, how can we implement these models in embedded devices? That becomes a little bit more tricky. That's one reason why we have a platform that kind of glues all those things together and makes it much easier. Other than that, there are different kind of exports of these models. So if you get into TensorFlow, there's something called TensorFlow Lite that is kind of made for stuff. Oh, someone asked, I would have to know a bit about Python to understand the coding part. I would say, don't worry about it as long as you're okay not knowing everything. I'll be walking through a lot of the code. So if you've never seen Python before, you might not know exactly everything that's going on, but I will be walking through the code, and you'll actually be able to run code cells. So don't worry, there's a lot of pre-written code here. So if you've never programmed before and you're okay clicking some buttons and not knowing exactly everything that's going on, you can actually still train a model yourself. Someone said, is there a product roadmap for 6 scale available? You know, I know we were making one that was a public one because obviously we have one internally. I'm not sure if it's live yet, but if it is, I can send that out to you or the email, I think. But that's a good question. I'm not sure if we have the public one out. All right, so someone said, what tool product would you recommend for splicing videos into images or frames? Oh, I know there's an online one that's pretty good that gives you a lot of options. I actually also have a Python script I made for it, and it's on my GitHub. I could share and talk about that later as well. So that's actually what I use all the time. Is I just have some script, and once you're set up, it's actually super easy. It hasn't really like hindered me at all. But we will have that feature coming soon, which will just make it quite a bit easier if you're not set up for it. All right, I'm going to get back into this. Make sure we complete on time. But again, I will be hanging out to answer more questions and go through the ones I haven't answered yet. So someone said pip install PyTorch. Well, we will be doing that. All right, did everyone make a copy who wants to run through the code? Again, just make your own copy here. We're going to be running code cells. Save a copy and drive. Someone said yes. I'll give you all another minute to do that. I'll share the link again too. To me, this is a really fun part. Someone asked a question about occlusion, which is where if you did have the labeling and something was actually just, if you had like a pen you're labeling and something was in front of it like this, would you label two sections here? There would be ways of kind of manually doing that from the exports. It's not a built-in thing to the tool yet. And we haven't really found in a lot of the cases, at least that we worked in, that you necessarily need it. So if you're doing something like this and you want to have this labeled as a pen, I would just label the entire thing, even if it's overlapping from the fingers. And it will look at both of those, but it should pick up pretty well that this is the pen here. Sometimes you really need specific use case for occlusion. There's different ways of going about it, but it isn't a built-in thing to the tool there yet. You could label two polygons, but it just wouldn't know exactly that it's the same object. So if you're okay with that, just detecting where a pen is, but not tying it to exactly the same thing, you could do it that way. Oh, someone said they only got boxes around their geese. Yeah, totally okay. We're not actually going to use, you're more than welcome to try to use your own data set as we go through here. I have a fully labeled data set with over 100 images of geese that we're actually going to train our model on. And then you can repeat all these steps for your actual labeled data set. So if you weren't able to actually do the labeling yet, that's totally okay. Just we'll still train a model together with a data set I will give you. All right, so I'm going to assume you all made a copy of this. I know some people coming late too. I saw some other numbers go up, so share this one more time. If someone asks for it too, if someone wants to keep track of that link and share it with everyone, that would be cool. Usually someone will ask for it later. All right, so this is Google Colab. It's essentially, if you've never used this before, it's essentially Google's way of hosting a Jupyter notebook, which is a very popular tool to use as a data scientist or machine learning engineer. It's a little bit different and there's a little bit more to it, but you can kind of think of it that way. If you haven't used a Jupyter notebook yet and you go more into this field, you definitely will at some point. But it allows us to write code, documentation, and output visuals all in one place, which is really cool. So it's really awesome for doing like experiments and like seeing what's going on, kind of having it in like a nice little flow. To be able to edit the code in this workshop, make a copy. Hopefully you already did that. So this is a text portion here, and you can double click on it and it becomes text. You can write in here. So if you want to keep notes as we go, you can also do that. To get out of this kind of edit mode, I'm going to hit Shift Enter, and it'll go back to this kind of formatted mode. And then just something to note, you don't have to do this at all right now because it's already set up to run on a GPU because you made a copy of mine. But if you are creating your own Colab notebook in the future to do kind of your own deep learning experiments, you can go to Runtime, change runtime type, And then select the hardware accelerator. So here, GPU is already selected. You get an option for a TPU, which is a tensor processing unit, kind of similar to a GPU for doing deep learning calculations. Or you could do none. So if you're not using deep learning at all, just have none selected, and it won't cut you off on GPU time. Code cells. So this is what a code cell looks like. It's kind of gray. Let me close that out. It's kind of gray. And to run this code cell, you can hit this little play button. And the first time you run code, like if you made your copy, it can take a little while to run. But once the first one runs and it's actually connected, so you can see it's kind of initializing up here. Once it goes through that step and then it's connected, it should be much faster to run everything else. So there, now I'm connected. I have this little check mark. You can also run code cells by hitting Shift Enter. So if you don't see me pressing the play button, I'm hitting Shift Enter on my end. You can create new code cells by hitting this plus code, or this plus text will do a new text cell. So again, if you want to add stuff to this as we go or later, you can definitely do that. And again, don't worry if you don't know any like Linux bash commands or anything, but I just wanted to mention that you can actually run kind of Linux whole bash terminal commands in here in the code cell, and you just have this exclamation point at the beginning. ls simply kind of lists out all the stuff in the directory. So you can hit Shift Enter here. It's going to say there's a folder called drive and a folder called sample data. I think for yours, it'll just say sample data because you haven't mounted the drive yet, which you don't need to do for this, but I will talk about it later. All right, so let's go ahead and install our dependencies for Detectron 2. I'm going to hit run on this cell. And again, you'll want to run all these cells in order. If you do get an error, especially during this first part, chances are you skipped over a code cell. So if you do get an error, just go back and run all of these separately. So I'm going to hit Shift Enter. This is a pip installing torch, which someone made the joke earlier, pip install PyTorch. It's kind of what we're doing here. The reason why it's here, you'll see that it says requirement already satisfied. So Collab already comes pre-installed with popular data science libraries like TensorFlow and PyTorch and scikit-learn and all the stuff like that. The reason why I have this here is because Collab also likes to update the versions of those libraries sometimes, right? So in this case, my code is relying on 1.7 of Torch being installed. And if they updated that to 1.8 in a few weeks, then this notebook might break for you. So if you came back to this in a few weeks and they had a new version in here, this would take longer to run because all the requirements wouldn't be satisfied. It would have to install the older version of PyTorch. Going to install a few more dependencies, PyYAML, PyCoco tools, because we're going to be using Detectron 2 and the Coco kind of dataset tool to load in our exported dataset. This is just kind of outputting the versions. That was just a sanity check for me, really, when I was making this. You don't have to worry about it. Then here we're saying pip install Detectron 2, and then it has this kind of link to the specific version. And this will take just a minute or so to run. Hopefully. Doop, doop, doop. Cool. Yeah, because a lot of stuff, again, is already in here. And it's just installing a little bit other libraries. And don't worry about this. It says restart runtime. That's actually, I think, for this new version of Pillow. But instead of restarting, I just have it easy. You can just hit run this next cell. That's going to install that version of Pillow that we need, which, if you recall, Pillow was the image processing library. And again, don't worry about this little warning. We don't have to restart our runtime right now. All right, now we're going to import all these dependencies we installed. It's a whole bunch of stuff from Detectron 2. You'll see that we'll use these later. If you've never used Python, we install libraries here, and then we import them in saying, hey, we want to use these libraries or specific things from these libraries in our program. And to do that, you have to kind of import them in. So it says like import Detectron 2. From Detectron 2, import specific stuff. And that's what it looks like in Python, getting these libraries. So you can hit run on there. And if you hit run and you didn't get any errors besides these, you should be good to go for the rest of the workshop. Someone said, are they programs or libraries? You could probably think of them as both, but most people would refer to them as libraries. So you're installing a library, and then you're using that library inside your Python code to create a program. But I mean, you could look at it either way, I think. All right, so I just want one person to say that this worked for them. Did that work if you were following along? Woo, okay, yay, we should be good to go. All right, so we already talked about creating a data set, but I do have links to here or on here in case people weren't here for that. And then also just again, Slack link. If you have any questions in the future about creating a data set, let me know. All right, so because for this workshop, again, it'd be hard to get everyone to actually label their own data set with the amount of time we have and train everything. We're going to use a pre-labeled data set that I made using Sense. So just showing the process, just like I did. I use the rectangles in this case, so we're going to use it for object detection. This is just downloading from a GitHub repo. So I'm just saying git clone this GitHub repo. Normally, I probably wouldn't store all my data sets on a Git repo, and I'll talk about that in a second, just how some other ways that you can import data sets for your own projects. So we downloaded this. This is just kind of listing out a whole bunch of images. This is what we're going to train our model on. And you can also see that, we have those JSON files that I talked about. Someone said they didn't have any warnings. Awesome. Well, maybe your code's even better than mine. I'm not sure why I had them then. All right, so we're going to use a Cocoa dataset, which is the version like I showed you how to export. If you're not using a Cocoa dataset, like in your job, you're handed a different dataset or something like that in a different format. You could go read the Detectron 2 dataset documentations. So they might have some other pre-built functions for different variations of datasets, but also it talks about how to build your own. So no matter what format your data is given in, as long as it has those coordinates somehow of like boxes and pixels of where an object is, you should be able to create your own custom kind of data loader. But most of the time, hopefully you'll have a data set or be working with a tool that you can export into a commonly used one like Cocoa. And then there's tools to get that data set in much easier. Someone said, why are you identifying cows repeatedly? So we actually do a fair amount of work in agriculture. And one of those things is looking at cows. So this example is just showing Smart Polygon working on cows. So if you're doing cow detection or something like that, you could do it. And this is just a GIF. So it's literally just repeating. It's not supposed to be a long video or anything. All right, so let's run this code cell. Oh, well, I'll go ahead and run this. Let me just talk about, so here, if we wanted to, so here we're looking at the data set that we just downloaded, and there's a couple ways of getting your own data set into Google Colab. And I'll talk about both of them and what I would do. So if you click on this little panel, you can click on this little file here, or this folder, and there's a button here that says Mount to Drive. If you click it, it'll ask you to do some extra stuff because you made a copy of my notebook. And what you do is, I think I had it as an import, but if not, then I think you just have import drive, and then you can run this piece of code in an actual code cell. This is just some text right here, and it'll come up with a little like authentication key, so you can authenticate your Google Drive account to this code, and then you can actually link to all of your folders. And what I would do is create a machine learning folder or a computer vision folder, have one for data sets, and then just upload your data sets to that folder. Otherwise, you can also literally just click and drag data sets up into here. So if I open my Finder and then clicked and dragged over here, it would upload that data set. So you want those JSON files and you want the image folder as well. But if you do that here, the problem with that is that it's only going to stay in there as long as your instance is live here. And with Google Colab, eventually you're going to shut it down, or it'll disconnect you after a certain amount of time or something like that, and you'd have to re-upload it. So what I would do is create a folder somewhere on your Google Drive outside of this, and then mount your Google Drive. You could always Google how to mount Drive. It's actually pretty easy. Once you do it once, it's just like a line of code. And then once you do it once here, it's actually even easier, because then you can hit this little button here and it'll say Mount Drive, and then you can explore your whole drive. So we're not doing it here because it's complicated, and I know someone will have an issue with it somewhere and it's hard to troubleshoot it. If you want me to go deeper into this later, ask me after the workshop or connect with me in one of those places like Slack or LinkedIn if you do have any issues with it. So it's a little bit more complicated, but it's not super scary. So don't worry, once you mount to your Google Drive, it's really the best way to repeatedly do kind of experimentation. But in this case, we download a data set and we want to look at those files. So this is what you would do if you mount it to your drive. So here I'm looking at that folder we downloaded from Git, but you could pretend that we navigated to this folder in your Google Drive because we want to do the same thing regardless. So here you can see that this register Cocoa instances, we're creating 3 data sets, the training, validation, and test. To create this test one, I want to have this path be to my, or sorry, to this train one. I want the path to be to my train.json file. So if you upload a data set to your Google folder and you navigate it to that folder, you would just find where it is. And then you hit copy path, and then you would just paste that path into here. And then this one is saying, hey, this points to the folder where that image folder lives, not to the actual image folder. So not this IMG folder, we want the folder above it. So if you uploaded your own data set, you would hit copy path to this folder above the image folder and paste that here. And that's true for all these ones down here are looking for those images, and all of these links are looking for the JSON. So we would have our validation JSON, copy path here, and you would do that for this one. Again, can seem a little complicated the first time you do it. Maybe you'll make a mistake, but once you do it once, it's very easy to continue doing this. And again, don't worry, you don't have to do this right now because we're going to train our model on this data set that we're already pointing to. This is just for you when you upload your own data set. And let me talk real quickly about the train validation test. Well, let's go ahead and run the next cells. And then when we train our model, I'll talk about it as it's training because it takes a little bit of time. So let's go ahead and run this code cell. This can take a second to do. But you can see here's some really cute pictures of geese. I love geese, and these baby geese were awesome. I collected this data set. So this is actually just at a park in Seattle, and I took pictures of geese and I trained a model on it. And what this is doing is this is loading in that dataset train that we just created up there. We're creating a new variable called dataset dictionaries. Well, I'll look at that in a second, but that's actually just the JSON file that we had before, essentially. So it's the mapping of the images and then the corresponding boxes around the objects that we're training for. And then here we're just saying, collect a random sample of 3. So if you rerun this code cell, it'll be different images. And then we're outputting this visualizer, which is kind of a thing built into Detectron 2. And if you see anything like this is usually reversing color channels of an image. So you have like red, green, blue, RGB. Opencv actually reads them in BGR backwards. So if you see anything like this is really just inverting those color channels. It looks like what is going on there, but it's so that you can do something in Opencv and then read it back, I believe. And then here we're just outputting the image with Opencv. And so this is really important to do. I would do this anytime you have a new data set that you've never actually worked with, because you want to make sure that you're reading in these labels correctly, especially if you're making your own data set reader or doing any customization in any way. You might mess up some sort of coordinate of the box. And so it could be drawing it backwards. Like if it was drawing the box over here, and then you tried to put those images into your model, it would never learn anything and just cause a ton of errors. And I've definitely done this before. So you should always make sure that the data set is read correctly. Here I'm going to print out, this is what dataset dictionary looks like. It's just a giant dictionary. Again, like I was saying, it points to where the file lives, in this case, images. And then it has stuff around it, like with the coordinates of those bounding boxes. To draw a rectangle, you need 4 points, and then the categories that those belong to. In this case, 0. Python indexing starts as 0. Oh, so someone's saying, if import Cocoa dataset is throwing an error because it already exists, what can I do? So don't worry about it right now, because it's just saying that this variable already exists. So you already ran the code cell. And then if you try to rerun it, it'll kind of yell at you. If this ever happens and you really need to recreate this dataset variable and you want to run all the code cells again, you go to runtime and factory reset runtime, and then you'll just have to run all the code again, including installing Detectron too. But it's because you already ran that code cell. No worries. All right, so training our model. Let's go ahead and just run these because it can take several minutes to actually train a model. It'll vary a little bit because Collab kind of randomly chooses a GPU for you. And I'm on a pro version, so I get often a little bit better ones than the free version of Collab. And so it might take like 10 minutes or something to train, but it shouldn't take that long. You'll see some output going here, and then we'll just let this train, and I'll talk about what's going on while this is happening. So first of all, the three different types of data set. So the training data is used to train our model. So we want to make sure that, most of the data, that's why when we did the export, it was like 80% of the data was for training, 10% was for validating, 10% was for testing. So you're feeding 80% of the data into the model to learn from. And then the validation data set is actually what we look at as a human. Like I kind of like to think of it that it's like the training data set for the human in the loop kind of. And what I mean by that is as our model's training, we'll look at this in a second, it's going to learn really well, like what a geese is in the images that we're training it on. But as it's training, we want to make sure that it's generalizing well enough to images that it never saw before, because otherwise it can just become overfit to those images specifically, but not work on different variations. So you feed it a data set as it's training after a certain amount of iterations. So we'll see that we're going to do like 50 iterations of looking at our data set. We're going to learn from it, and then we're going to see how well we do on this data set we've never seen before, which is the validation one. And we'll get some sort of score from that. But then I, as the human, can use that score to make adjustments to my neural network. So there's all these hyperparameters and stuff we can tune based on the output from that validation data set. And then the test data set is something we look at once we feel confident that it's doing good on the validation data set. And now I want to see that it does well on a data set that the model never saw and that I never made any adjustments from. So I can make adjustments while looking at this data set, but I shouldn't make adjustments to the model while looking at this kind of separate holdout test data set. So it's very common when you're doing deep learning that you have these three different types of data sets for you to look at. And I always just kind of like to think of it as the validation one is for the kind of the human in the loop to make adjustments or tweaks to the neural network as it's learning. Someone said, are all these data sets full of geese? So this data set is just a data set of geese, and we'll look at how many in a second. So now that our model's training, so I link here. Let me talk about this real quick. So again, you can go read all the documentation on Detectron 2 to go deeper into all of these kind of subjects. There's something called a model zoo for Detectron 2. So when we showed that it could do things like feature points, it could do object detection, it could do instance segmentation, you can go and find all those models there, and you can change a parameter, which I'll show in a second. So depending on what you're trying to do, you can go to that model zoo and say, I want to do a single multi-box detection model versus a faster mask-R CNN. Or you want to do feature points versus detection. And then optional, you can go read this article. I won't share it in the chat because you already have it in your notebook here. This talks about, so when we talk about doing that validation data set, Detectron 2 doesn't automatically have a way built in of doing the validation, which is kind of annoying. A lot of other frameworks do, like if you're building this out in TensorFlow or PyTorch, I think, well, maybe not a pre-trained model, but a lot of times there's ways to more easily do validation. So I have an article in here that goes more into building this validation function. But we built a class here, and essentially all this is doing is saying, hey, after a certain amount of iterations, which we have as a parameter down here, we're going to run our model on this validation data set and then give an output for it. So here are the parameters for the model. This is kind of how you configure one to run. And again, don't worry if some of it's over your head. If you've never done a lot of Python or anything like that, you can always come back to this and kind of pick it apart, or even just run it, and it should work pretty well for a lot of your data sets. So here we have this variable called config. It's kind of just how you set it up. And then here we have this merge from file, and then we say model zoo.get config file. And this is where I talked about you could go to this model zoo and find a whole bunch of different types of models for whatever you want to do. In this case, we want to do detection. So there's something called COCO detection, and we're using a faster mask-R CNN. But if you wanted to do instance segmentation, like the polygons, I even have a quick thing. You could just take this and change that path out right here. So all this red text here, you would just put in this new one. And then you also want to do it for this one down here. And this parameter is reading in the weights. So when we talked about transfer learning, if we didn't have any path here, pointing to the same file destination, it would start from 0, and we wouldn't be able to get good results just on the 300 iterations that we're going to train on with our 147 geese or something. This parameter is pointing to your dataset train. Very important. If you don't have this comma there, it'll yell at you. It took me a long time to figure out. I had an error and I couldn't figure it out. That was why. So just as an FYI, so don't forget the comma. That makes it a tuple type in Python, and that's just what it's expecting. I think it's so you can read probably multiple data sets in. And we have num workers. You don't really have to worry about this. This is for more advanced things in PyTorch if you want to modify kind of how you're training across processors. We talked about this. You always want this, if you're doing transfer learning, to match up with whatever the path is that you put here. Images per batch, just by default, we're loading 2 images in and looking at them. You could probably make this a bit more. It might kind of make your training maybe a little bit faster. It shouldn't already be too bad. Base learning rate. So this is a learning rate we're going to start at while training. I won't go too deep into this, but it's a very important thing for the kind of algorithm that trains a deep neural network. So if you do have issues on your data set, one thing you can do is look up kind of learning rates and adjust it. This one will probably be pretty good for a fair amount of kind of easier to learn things like geese and stuff like that. But something to look at in the future if you are having issues. This is important. So this is saying max iteration. This is kind of how many times we're going to look at our whole data set and learn from it. So 300 is what I have here. If you have a more advanced data, like more complex objects, not just geese that look the same, you probably will want to add more. So in this case, 300 is actually going to give us probably pretty good results. But if you have a more complex data set or something like that, you might want to put in like 1,000 or kind of play with it there. This is just saying how many instances might be there per image. So it's saying a max 32. This is super important. You might want to change this depending on the data set. So if you are only doing one classification, in this case, we're only looking for geese. And someone said something about they were looking for cougars. This would be a class of 1 because we're only looking for one type of animal. But if we were doing geese and ducks, we would change this to 2. If you're doing geese, ducks, and pigeons, this would be 3, and so on. So just a very important parameter to change depending on how many classes you're trying to predict in your data set. And this is just creating a new directory. We have output. This is where our model is going to get saved to. And then this parameter here is saying every 50 iterations, go run the model on that validation data set so we can see how well our model is doing while it's training. And this is the variable for that validation data set that we created earlier. And let's look at this output. So all this crazy stuff here, this is actually the architecture of, I believe it's ResNet, which is a underlying, this is RCNet. Yeah, ResNet. It's the underlying architecture for a convolutional neural network that's used in the code, and it's just outputting it here. So you can look up convolutional neural networks, and they're actually just kind of composed of a whole bunch of different things, which you can see being put out here. Here it's saying we're going to look at all those images you gave us. There was 110 images, so not that many, but a lot of the images had more than one goose in them. So there was 260 instances overall of geese that we're going to learn from. And then there was 37 in the validation data set that we're going to look at as we train. And we'll get some output over here. This is the important stuff to look at. Is this average precision. So AP stands for average precision. And I have a link, I forget if it's, I think it's down a couple of code cells, and it goes way more into reading these types of metrics. So don't worry about it. All you really want to know is that these should go up. So it's doing a measurement saying like, hey, here's the labels of those boxes that you gave me. And I'm predicting my own boxes. And if they're not quite on them or they're skewed in some way, that's kind of where the average precision comes in. So if it's predicting boxes that are way off, it's going to be a much lower score. So you always want these to go up. It looks like it's going up, going up. And then they're going up pretty high here. So we scroll down all the way. We can see at the end on the validation data set that is actually 81% average precision, which is pretty good. For just, we only trained it for 300 iterations, which isn't a ton. And then also these are different ways of looking at it. So you have the average precision and then average precision of, I think, different sizes of it. So you can see it's very high here and then just kind of across the board. Oh no, sorry, it's not sizes. It's thresholds for how confident it is. So we'll look at this in a second, but you get a confidence score returned. So it'll be something like, I'm 90% sure this is a goose, or I'm only 60% sure. There's something called Tensorboard. So this is a really cool way of evaluating your model as well. Like once it's trained or even during training, a lot of times you can bring this up. I'm not sure if you can in the notebook because it can only run one cell at a time. But if you're doing this outside of a notebook, you can come in and look at everything here. And sometimes people said during the workshop that for whatever reason, it won't load. And hopefully mine will show up in a second. There we go. It might take a while. Some people have said it never comes up. So if it doesn't, sorry, I don't know how to fix it, but it's okay. If it doesn't come up, it won't hinder any of the other code cells. So here, so someone said it took like 10 minutes. Oh man. Oh, I guess I should have asked too. Did everybody's model finish training? Okay, yeah, I see some people are still running. A lot of people are done. I'm going to keep going, and you should be able to catch up if you're not quite done yet, if that's okay with everyone. Also, just want to say congratulations. If you've never trained a computer vision model before, you've now done it. So I know you haven't seen the output. It's not super exciting yet, but we're going to look at the output. But you trained maybe your first model, which is really cool. Maybe your first deep learning model ever. All right, so Tensorboard is up here. We can look at kind of different parameters. We can see that the AP, the average precision, is it looks like it's still going up. So if we trained it for more than 300 iterations, our model would probably keep improving here. And this is the average precision on the validation data set, which is great because training accuracy on the training data set will almost always go up. If it doesn't, then probably something is going on with your model or reading the data, it's doing something wrong there. Sometimes it can plateau, but it should kind of keep going up to get close to 100. But here we can see AP, it's doing good. And it looks like it's still going up. So maybe we could keep training our model and improve it. If we go and open up some of these other things, you don't really have to worry about these too much right now. But there's a whole bunch of metrics in here you can dig down into. But one thing to look at is like you can see class accuracy, you want to make sure that it's pretty high. It looks pretty high here, 90 something. And this is on the training data. So again, like I was saying, the training data should always be going up or plateau kind of like this. If it doesn't, if it's like really bad, then it's having a hard time understanding the data that you gave it, and it can't like figure out the things that are making up the, in this case, geese, right? So for example, I've had this happen when I said like if I read in the bounding boxes wrong, I was able to tell I did something wrong somewhere because this thing was like, I don't know what you're looking for. This doesn't make any sense to me. So it's a really good thing to kind of verify as you're training that these numbers are going up and false negatives are going down. And some other stuff in here too. Again, if you go more into kind of deep learning or drill deeper into computer vision and stuff, all these kind of metrics or a lot of these metrics will come up again at some point. All right, so now we have our trained model. Again, congratulations, especially if that was your first deep learning model. You can now put deep learning on LinkedIn, right? All right, so setting up a pre-trained or setting up a trained model is very similar to setting up a model for training, except for there's a couple different things. So one, we don't pass it the training data set. but we still want to define the model that we're going to use. So we know that we trained our model on that COCO detection, faster mask-scar CNN. But if you did change this to that instance segmentation or feature point models I was talking about, you would also want to change this here. So this path needs to be the same as however your model was trained. So we're saying this is the model architecture, but instead of loading the pre-trained weights in, now we're going to load our own weights in. So this is looking at this output path, and you can see that there's model final.pth. That's the PyTorch version of saving a model. And that's what we're getting here. And then we're going to put a data set in test, and we can run validation metrics on this. And then this is super important. You do want to change this parameter if you had more classes in your data set. So again, if you're doing like geese and ducks, you would change this to 2. If you leave it as 1 and your model is trained on 2, it'll still try to make, I think, predictions for 1, but it won't understand you want 2. So again, very important to change this to be whatever it was that you trained on. And then here, this is really cool to mess with. So I'm going to leave this at 0.9 right now. That's saying, draw a bounding box around a object if you're 90% certain or confident that it's that object. But a lot of times your model might not be that confident, and it might be like, well, 70 or 60 or something like that. So if you are training this on your own data set and you're running the model and you get to the point of trying to draw out the predictions and it's not working, try lowering this. So you could always try lowering it to 50 even or whatever, make sure that it's drawing stuff. It might be like way too many bounding boxes at that point. And then you can incrementally put it up higher. So like 80% might be good or something. And then we're making a variable here that's a function that we can then pass an image into, and it'll return the predictions of where the geese are and how many there are. So let's go ahead and run this if you didn't already. And it can take a second. And then run this next one. And this is doing something very similar to when we were just outputting our data set before, but now we're actually outputting the predictions in. So here we're saying, hey, test image path is this image. This is from our test. I made sure that this image was from the test pile, not from a learning one. And then we're saying image is equal to the CV2. That's the CV2 is Opencv, and it's reading in that image path. And then we're getting some outputs, and we'll look at this in a second. So we're feeding the image to the predictor, and it's going to return outputs. And then we're using the visualizer method from Detectron 2, just like we did before, to kind of visualize those outputs. But we'll look more closely at those in a second. This is actually where we're drawing those visualizations, and then we're outputting it with Opencv. So if you ran that, you should have gotten some sort of prediction. And hopefully it's drawing boxes around geese. You could let me know. Did this work for you? Someone said, yep. If so, awesome. You have a successful computer vision model that is doing object detection, which is super awesome. Again, if you've never done it before, it's really cool. It took me a lot longer to get to this point when I was learning, because I feel like people, again, didn't really go into like creating data sets or object detection, at least the material I was going through. And I was like stuck with all this other stuff for a long time. And I think this is really exciting because you can actually do a lot of cool stuff just having this knowledge. So real quick, let's look at what an image looks like. So like I was saying, it's actually just an array to Python, right? It's just like a multi-dimensional array. These are different color channels and pixels. So like where a pixel lives. Let's print out what the predictions actually look like. So here we can see that we have some fields. It's kind of like a dictionary here, or like a tuple with multiple fields in here. We have number of instances, some information about the images. And then this is the important part of predicting where these boxes are. So this is giving us output of, again, drawing where these rectangles are. We have 2 sets of them because we have 2 geese here. And then we have the scores. So in both cases here, it was very confident that those were geese based on what it knows about geese. So here was 99 and the other one was 98% sure. And then this predicted class, it says 0 and 0. That's because we only have one class. They're all geese. If we had geese and ducks, it could be like a 0 would be a geese and a 1 would be a duck. Again, with Python, indexing starts at 0. So you can think of 0 in this case as like, it's class 1, which is in this case is a geese. And so having this is actually really neat. So this is often what you need to do something functional. You don't always need to write out this visualization. Like, this is awesome for us to see as humans, but from a programming perspective, right? Like, you probably don't need your code to, like, see the visualization. It can see that based on these bounding boxes. And so let's say, for example, you just want a notification saying, hey, an animal's here. Like, how many of that animal are there? Like, is it a pack of cougars or wolves, or how many geese are there when you have your notification sent to you? And you can just count easily how many there are by doing, getting instances, or just getting the length of how many objects there are in there. Oh, and if you see this, so it says to CPU. So when we're running the inference from our model and saying, hey, look at this picture and give us a prediction, we use a GPU to do that because GPUs run deep learning models very well. But then once we have the output to do things like this with the rest of the Python, or just outputting it and doing other stuff with it, we want to move that from the GPU to the CPU. So if you see to GPU or to device or something like that a lot in PyTorch, that's what's happening, is you're moving something like predictions to a CPU so you can do different stuff with them, or moving something to a GPU so you can use the GPU to run a model. So here, right, like this might be what you want your program to do, is detected 2 geese. If there was 3 in there, it would say 3 geese. So pretty powerful, just knowing how to do something like object detection. You could also look at these bounding box coordinates and do calculations like, did they overlap at all? If so, like, are they, touching? Are they not social distancing? Something like that, depending on how your camera angles are set up. That's really the important stuff, is understanding, where something is inside of an image and what it is. And then once you have that information, that's up to you, like, what solves your problem. So someone said, except all the people go, ooh, ah, on the visualization. That's a good point. So, you should totally use visualizations, post them on your LinkedIn or whatever. They're really cool. People do go ooh and ah. And yeah, I recommend using them. But I was just saying, if you're doing something like sending a notification to you, you might not need to draw them out. Maybe you do want to draw them out too, though. Like, if you have a notification, but then you want to have a person understand where something is, you probably do want to draw a bounding box around it. Here's just another example. This is, again, geese in my living room. If anyone sticks around after the talk and they're curious, I could talk a little bit more about this and show some other examples. But I already mentioned it's something to do with like creating a synthetic data set. And then here, we just go ahead and run this on that separate test data set, just like we did with the validation one. But now we didn't use it for any tuning, which we didn't do any tuning anyway. But you know how to now. So when you're doing your own data set, you could do this. And we're just running those metrics, the average precision metrics, on our test data set now. And so it's like 80%. Cool. I feel like that model's good enough. Let's go ahead and run it on a video now. So here, I'm just displaying a YouTube video. I have this video posted just solely for this purpose. It's just some geese walking around. And we want to run our classifier on this so we can actually track where they are the entire time. So we're going to pip install a library called YouTube DL, YouTube download. Makes it easy to download a video from YouTube. And then we're going to say YouTube download, point it at my video there. Frame rate is 22 frames per second. And we're going to save the output, that's what the O is, as video.mp4. So I'm going to hit run. And then we're going to use the library. So you don't need to do this because the video is pretty short, but we're going to go ahead and use this library called ffmpeg and create a 6-second segment of that video. The reason why is I do this a lot. If I am going to write out visualizations from a model to a much longer video that's maybe like a minute long or something, I want to make sure that it's actually working before I wait, because you'll see it won't take that long for this video. But if you are running on something like a minute plus long video, it can take a while. So I always like to do kind of a sanity check that it'll work. So you could change this to longer. I think the video I have is 12 seconds or 11 seconds. But essentially, we're just creating a 6-second clip from that video we downloaded. And if you didn't want to do that, so we saved that clip as videoclip.mp4, but we also downloaded the original video here. So if I wanted to, or if you want to do this, I won't because it'll be faster on the 6-second clip right now. You can hit copy path, or you can upload a video to your drive, or in this instance, and again, navigate, just find where it is, hit copy path, and then change this part here to whatever the path of your video is. You can see it's like, hey, it's in content, video.mp4. And then it'll write the visualizations to the whole video. So I'm going to go ahead and run this, and then I'll talk about the code because it takes a minute to run. You should get some sort of output like this. And it's going pretty fast. So essentially, we're reading in a video with Opencv, getting some information like width and height. Actually, yeah, we write it out with this. Information like frames per second. You can do all sorts of stuff with this information if you want. Like I actually use this to make really cool videos with models running on them, and sometimes use this to do different stuff based on like frames and stuff. And then we're creating a variable called video writer, which is using Opencv to write out a video called out.mp4. You have some other variables you can do here, like what is the frame rate you want and stuff. We're just leaving it at the default frame rate. And then creating a variable phi for video visualizer, which is a built-in thing in Detectron 2, which just makes it easy to run the model on a video. And we're getting the prediction just like we did with the image. And we're creating a variable called frame, which is taking that image and then converting it from RGB to BGR, like I was saying, because Opencv reads things in BGR, so we want it in that. And then a variable called visualizer, and we're drawing those predictions with the Facebook video visualizer. We're passing it the frame, which is the image we just read in, and then the outputs. So automatically parse the outputs like we looked at before, figure out where to draw those frames on the image. And then again, here we're just reverting the color back, RGB to BGR. And then we're passing this visualization out of the loop. And then for each one of those visualizations, we're just writing it with that Opencv writer method. And then here, this is common with Opencv, you kind of destroy the things or close the things you were working with. And then I'll just hit download here. And this can take a second to download, more than a second, several seconds, or a minute. Is this working for everyone? It's been a little quiet in the chat. I'm getting worried. Okay, people are saying yep. Some people are saying, how do they change the path? So if you want to change paths for anything, and you know where it lives in here, you can just navigate to it, copy path. So if I wanted to do this on the full video, for example, I would change this here. I'm not sure if that's what you were asking about. So changing paths, it's easy to just kind of find out where it lives in Google Drive or in your Collab instance through this little navigation pane. Again, you can bring it up by clicking one of these, going to this folder icon, finding where something is. Sometimes you have to drill down if it's in a folder, and then you can just right click on it and hit this copy path and then adjust that. So if you were looking at bringing in the model or anything else, you could find where your output model lives, copy path, and then paste that in here. This one, you'd actually get rid of this config output, and you could just go straight to your model here. You would want to make this a string, so we would put quotes around it. And I got a download here. It's just called out57 because I've done a whole bunch of outputs. And ta-da! It's running on geese and detecting geese, drawing rectangles around them. And if you did this and you got the download, and maybe it was your first computer vision model, if so, that's awesome because it's kind of advanced to go straight into building something like object detection. And now you have the knowledge to kind of do this on your own data set. and hopefully solve any cool problems you have, or if you're already working on a problem at work and you just never kind of gone through the entire process or weren't sure how to label things, you kind of have all the steps now that you can do this. So there's a whole bunch of other links in here if you want to keep learning. Again, the Slack channel is a pretty good place if you have questions for me later. I'm posting a lot more stuff on Medium soon, as well as I usually do kind of a weekly AI article. So it's like everything happened in the week and tool updates and podcasts and stuff like that. YouTube, there's going to be a lot more on there soon. I think I'm going to be working a lot of cool stuff, and I have a link to my other talk talking about the synthetic goose data set, and then a whole bunch of other links to kind of deeper articles on all the object detection methods I talked about, like single shot multi-box detection and everything like that. I have like the official papers and then a little bit more casual articles that aren't as dense as the papers. And then I'll share all these links in the chat, and I'll also be hanging out. So if you have any questions, let me know. I'm just going to stop recording real quick.